Hello, everyone. My name is Liam McDonald,
I'm Ashik Dilip Kumar.
I'm William Usding.
and this is our semester presentation for our Circuit Tutor refactoring project.
Project description and motivation. So we're going to run through behind what was the motive behind this project. So our main objective with this project is simply to take Circuit Tutor as it exists in VB6 and convert it to VB.NET. VB6 is beyond the point of an aging platform and limits the user base to Windows users exclusively. VB6 is an interpreted language that lost its long-term support from Microsoft in 2008, lacks many staple features present in the modern compiled languages, and only runs on Windows devices. VB.NET, on the other hand, is a far newer and runs on Microsoft's current .NET framework and can be run on any device where a .NET framework can be installed. Thus, the conversion from VB6 to VB.NET will vastly modernize the project and help Circuit Tutor move to the future. But to do that, a lot of work needs to be done. To start, we first needed to understand the differences between the two platforms we were going to be working with. To do this, we wrote various small programs in VB6, converted them to functioning programs in VB.NET, and compared notes. Doing this gave us deep insights into some of the troubles we'll run into in the future, and in many cases, we were able to learn the functionality would be preserved outright or that there's a simple means of implementing them later on. This sets up nicely for the second phase, where we've actually ran preliminary conversions of the Circuit Tutor project. These preliminary conversions, however, contain tens of thousands of errors that need to be addressed before we can even run the project. So our efforts now are focused on characterizing these errors, developing manual fixes for them, and finally automating them. Next, we will go through the development of requirements. The basic requirements were quite straightforward. The sponsor had made it very clear that we must use VB6 and VB.NET. As such, each of us individually had to install VB6 and VB.NET in our Windows systems. We were also asked to use Bitbucket as the source control system. It was also mentioned to us that we must research for various companies that were willing to offer the services of utilizing their conversion tools, provided these said conversion tools were cheap or even available for free. Throughout working on this project, we were also asked to keep in constant communication with the software engineering Capstone teams in order to work in collaboration and ensure that we are on the same page. We were initially asked to primarily focus on setting up the required platforms and begin to understand the differences between VB6 and VB.NET. As the project has progressed, we have focused our efforts more on converting the Circuit Tutor project itself. Within this, the sponsor has asked us to automate as many of the changes as possible and implement as many of them in VB6 as we can. Through the weeks of meeting with the sponsor, we were asked to set weekly goals for each individual in order to be efficient and produce faster results.
To begin producing results, we needed to select and justify our selection of various technologies that we'll use along the way. To start, Visual Basic 6 is an IDE that came out in the late 90s and is generated by Microsoft itself to work with VB6 code. This is where the Circuit Tutor project lives currently, so it makes sense for us to start here. We've utilized Visual Basic 6 not only to look through the current working versions of Circuit Tutor, but also to create dummy programs that we've converted along the way to understand how functionality can be preserved in later versions of Visual Basic. Next, we use Visual Studio 2008 to upgrade the projects from VB6 to VB.NET. VB6's long-term support ended in 2008, so Visual Studio 2008 is the last version of Visual Studio that includes a conversion tool that allows you to automatically convert projects from VB6 to VB.NET. Therefore, we need Visual Studio 2008 to use this tool to start moving towards more recent versions of Visual Studio. Next, we upload the projects into Visual Studio 2013. 2013 has a one-way conversion tool that modernizes projects for later versions of Visual Studio and allows us to continue to use the same projects that were converted from Visual Studio 2008, but also utilize more recent .NET framework versions. Finally, we're utilizing Python to make automatic changes to the VB.NET code in order to make it closer to a running version in Visual Studio 2017. We use Python because it's easy to use and has lots of features that are great for text replacement that makes sense for modifying code to fix various errors that the conversion tool didn't fix itself. Of these include various array dimensioning errors, as well as semantic errors that have changed over time. Finally, we're using Visual Studio 2017 and Visual Studio 2019 as more recent versions of Visual Studio to start working in and looking at the VB.NET code. Using these recent versions allows us to potentially use newer .NET framework versions in the future and allows us to see what errors currently exist in the project.
In this section, we discuss our design details and justifications of decisions. It's split into two parts, the research and implementation. In research, we spent most of our time going through different topics, and they were split among the different groups and team members. In this, we also created dummy programs to show simple processes and other programs and commands in VB6 that could easily be converted. We also researched conversion tools that could easily show what the process in VB.NET would be. Final decision of this was just to use the Microsoft's conversion tool and just hand fix errors that popped up. In implementation, we slowly started to fix VB6 code to fix conversion errors that we could. We then slowly transitioned to VB.NET code after discovery that most errors were only found in VB.NET. And we are currently using Bitbucket to share branches and fixes with the other teams. We are also creating scripts to fix the abundance of certain errors that only require small fixes like the example shown, where in the VB6 code it's the array with 2 parentheses, while the 2-dimensional version of VB.NET requires a comma in between the parentheses.
From our investigations in the VB.NET code, we've utilized several areas where we can start to improve and implement fixes that will help us move towards a working project. Of these errors, there's an overwhelming majority of array dimension errors that was shown as an example in the previous slide. These topped out over 16,000 in total count throughout the entire project and really dwarfed all the other errors by comparison. But still, in total, there were about 24,000 errors to break down, and we've started to make sizable progress towards reducing those and getting everything to a more manageable state. So to start off with, as again you can see, there's an overwhelming majority of array dimension errors that really took over the project and created a scary number of errors that seemed daunting to fix in the beginning. However, utilizing Python and what we learned from our research phase, we were able to quickly get rid of those errors so we can start to focus on new ones. However, as you can see, there are still a large number of errors that need to be tackled, totaling around 980. But now with the largest out of the way, it's easier and more manageable to start breaking apart the current project and work towards a more manageable running result.
In this next section, we'll show what we brought to the table of the circuit tutor design refactor. In the beginning, our team wasn't able to bring as much to the table as the other teams. This was mostly due to us not having a good way of communicating between all of us, our team being one of the smallest teams in the group, and us having less experience both in the field and on the project. However, once we started looking into the code after doing our research, our team was able to bring up a lot of errors to the other teams to start working on. Once we started delving into the errors of the code and conversion, our team was able to bring a lot more to the other groups and sponsors. We were able to show a whole list of potential errors and problems in the VB6 to VB.NET conversion and how we can easily fix them. However, we don't know all the answers to the solution, so we were able to split it between the different groups, with the software engineering team mostly focusing on graphics and the other software team focusing on current problems that they were working on and other ones that they could find and help us with. Our group was also able to make scripts to help fix these errors, like the one Liam showed in the previous slides that fixed the array issues. We are continuing to work on these to help implement and fix these problems in the VB.NET conversion.
Along the way, we've learned a lot about VB6 and VB.NET, but we've also learned a lot about what it's like to work on a project. Chief among this is that requirements aren't always straightforward. The project sponsor doesn't have full knowledge of what we're working with, nor does he have full knowledge of the terminology that relates to a lot of the technologies and features within the platforms we're working on. Therefore, it can be difficult sometimes to communicate between the sponsor and the teams what exactly we're looking after and what exactly the expectations are. We've also learned that communication can easily fall apart and is much harder to put back together. It's easy to stop communicating with the team and no longer be in sync with everyone on it, but it is much more difficult to play the catch-up game and get back up to speed. Furthermore, we've learned that it's important to balance between project progress and sponsor expectations. Oftentimes, the sponsor's expectations result in practices that aren't common and aren't efficient, but it's up to us to find ways to not only meet the sponsor's expectations, but also push forward with the project and continue to make measurable progress.
As we look forward to the future, here are our plans for the next semester. We plan on finishing the development of the current scripts. We also plan on utilizing the concurrent features to support multi-threading and multi-processing in these Python scripts. We plan on continuing to fix minimum errors in the VB.NET environment. And we also plan on keeping up with the new VB6 commits from the sponsor, which utilizes the previous scripts and makes the manual changes as needed.
Again, my name is Liam McDonald.
I'm Ashik Dilip Kumar.
I'm William Usdane.
And we want to thank you for listening to our presentation, and we look forward to presenting more progress to you next semester.